Hey there, it's Mr. Meises here, and we are going to be looking at a basic introduction, look at some problems to kind of an Algebra 2 level of the normal distribution and what we would use the normal model to do. So I'm going to run through this. This is going to be speedy, so you just kind of keep up. So we have when we're looking at what we call a distribution, that's basically when we're looking at data in maybe like a histogram or a graph of data. Negatively skewed data would be data that are not symmetric, that there are more on this side than there are on this side. Positively skewed is just the opposite, more on this side than there are on this side. And then a normal distribution is symmetric. We call it unimodal too, meaning there's one mode. But really what I want you to know right now is this is symmetric, and we're going to talk about the more important things in the normal model. This is a model. It models population. So what we do is we're using this normal distribution to model some percentages of our certain population, of people, of things, of anything that we're taking some data from. So let's take a look at some examples here, and let me explain to you what we're going to do here. So we use the normal model a lot in real life, all over the place, and if you take AP Statistics someday or any stats class, you'll see how we use the normal model in nearly everything that we do when we're analyzing data. And it's really important when we're taking a piece of statistics called inference, when we make conclusions about populations, and just based on some samples that we take. So what is this normal distribution? Well, what we're going to use here, and forgive my pink there, I've got another picture there for you, but we're going to use something called the empirical rule. All right, and basically what the empirical rule states is that this middle line right here, this is our mean. This is our average, okay? This is our mean, and we call the mean, we use this little symbol mu here, but this is basically our mean and our median. So it's the same thing, meaning that 50% of the data are over here, and 50% are over here, right? Half and half, because it's the median. Now, one thing to remember here is that this entire picture here needs to add to 100, because the population is 100% of the population, right? Not 5%, it's 100. So the whole thing adds to 100. So here's what this says. Each of these spaces is the mean plus a certain number of one standard deviation each little space. So this is the mean plus one standard deviation. So I'm just going to say plus one standard deviation. This is plus two standard deviations. This is plus three standard deviations. And if we're going to go this way, this is minus one standard deviation, minus two standard deviations, minus three standard deviations. All right? And we would just subtract or add the standard deviations from the mean to get these numbers down here. So what is the middle part saying? Well, what the middle part tells us is that in between one standard deviation, well, there goes my text messages. Oh, everybody's so good. In between one standard deviation of the mean is 68% of the population. So 68% of whatever's going on is going to happen between one standard deviation. Even more rare is between two standard deviations is 95%. And then finally, between three standard deviations is 99.7% of the population. 99.7% of everything of the population is going to be between these numbers here, and you'll see an example of what I mean when we talk about this in the next example. One way you might want to write it to just to give you a simple way of remembering the percentages when we do these problems is you can write each of these little spaces is 34%, then 13.5, and then 2.35%, and then 0.15%. And I'm not going to use this because I want you to be able to do some things with some simple subtraction, but this does make it easier. I just want to tell you, this does make the problems that we do easier. So I'm going to stick with the empirical with 68, 95, and 99.7, and I'll show you what we do. The important thing to remember is that the whole thing has to add to 100 depending on where we are. All right, so let's take a look. So we've got Mr. Sung He gave a test in his algebra class of scores normally distributed with a mean of 85 and a standard deviation of 3. So this is what we do, guys. All we do is we go to the mean, and we say mean, it's 85. So I'm going to go 85 here. And then I'm just going to add 3 each time to get to my next space. So I'm going to add 3, I'm going to get 88. Then I'm going to add 3, I'm going to get 91. I'm going to add 3 and get 94. And then I'm going to do the same thing that way, except I'm going to subtract. So subtract 3 and get 82. Subtract 3 and get 79. And subtract 3 and get 76. And then I'm just going to label it 68%, 95%, and 99.7%. Okay, that's going to help me out here. Now, what I want to mention here is, like I said, it has to add to 100. So let's just say, well, let's look at what percent of students would you expect to score between 82 and 88? So here's 82, here's 88. All right, so what percent is in between that? 68%. So that's all you have to say, 68%. What percent of students would you expect to score at most 82? So here's 82. At most, meaning that they can't score any higher than 82. So nothing higher than 82 is all of this space right here. Okay, if in between these two is 68 and the whole thing has to add to 100, all right, 68, 100 minus 68 is 32. That means that both this part here and this part here has to add to 32. So what's just this part? Since it's half of it, it's half of 32, which is 16. So what percent of students will we see just right here in this part? 16%. All right, again, so we're just adding and subtracting from 100 here. So if there are 40 students in Mr. Sung's class, about how many would you expect to score between 76 right here and 91 right here? All right, so we got to do, again, we got to do a little subtraction. And if you go up to the very top and you look in the previous slide here, this little space, this little leftover right here is 0.15%, or yeah, it's 0.15%. So we'll go back here, and we'll label the parts that are missing, so we can figure out the pieces that we need here. All right, if we did that, we know that this is 0.15%. This right here, this whole section, these both these two, and we add it up together, that's 2.5%. So what we need to do is we need to take 100% minus 0.15% minus 2.5%. And when we do that, we're going to get our percent of the percent of ones that score between 76 and 91, and we're going to need to multiply that by 40, which is going to be 97.35%. So then what do we got to do? We got to multiply by 40, so we're going to do 40 times 0.9735. That's a percentage, right? We got to move the decimal over. So 40 times 0.9735, I'm going to use my little calculator here, is 38.94, which is 39 students. Okay? All right, so we're just doing a bunch of subtraction with hundreds here, so let's take a look at another one. All right, so then we're going to label this one, so hopefully you've read the question. So we're going to go and label it 68, 95, 99.7, and again we got to figure out what goes on the bottom here. I'm going to use 30 instead of 30,000. It's going to get too hard to fill that in. So 35, 40, 45, and then subtract 25, 20, 15. What percent of tires will last between 30,000, so right here, and 40,000 right here? So we got to do some subtraction. Or what you could do is you could look at that pink one and add them up together. All right, so you can add all these up together. But what I can tell you is that there's 50% on this side. All right, and then right here there's 2.5% right here. So what I'm going to do is just take 100 minus 50% minus 2.5%, and that'll get me what's in the middle right here, in between these two. and that's going to be 47.5%. All right, so let's take a look. How many tires will last more than 40,000? So that's everything up here, more than 40,000. Well, 2.5% are going to last more than 40,000, so I'm going to say 0.025 times 40. How many? Oh, 10,000. 10,000. Sorry, 10,000, because that's how many we sold, right? And that's going to give us 250 tires. About how many tires will last less than 25,000? So here's 25,000. We want less than that. That's over here. Okay, that's going to be 16% total. So I'm going to multiply 0.16. There's my bell. Got to hurry up. Times 10,000, because that's how many tires we sold. And that's going to be 1,600 tires. All right, so we're just using the normal model, the percentages, and multiplying. Okay, so the next thing I have here is if I can find my little, oh, it's up here. The next thing I have here is a practice problem. So if you just want to take a second, and then I'll write in the answers here, and then you can just take a look at it, and I'll be all done. Thanks. And here are your answers. So that's it for this video. We will talk to you soon. Bye.